I'm Marion. I'm a data scientist at Specsavers, and I'd like to actually start this talk asking you a question. I would like you to raise your hand if you've had a sight test appointment in the last 2 years. So don't be shy, just raise your hand. Okay, so that's about like 20% of the audience, I would say, about that, maybe 30. So I think something that is very important to know is that a visit to your optometrist isn't just about getting a new pair of glasses. At Specsavers, our optometrists are trained to recognize abnormalities in your eyes by examining the internal and external structure of your eyes. And in order to detect conditions such as glaucoma, which is one of the leading causes of blindness in the world and is often symptomless. And this is why it's so important to have tests that can detect changes in your eye health in order to detect those conditions. So like I said, very important to have routine checks to track and monitor your eye health over time. So at Specsavers, we recall our customers for eye tests every 2 years. And we do that because for low-risk patients, it's inconvenient and unnecessary to have tests more frequently. And it also book up appointment slots that could be given to customers with greater needs. So what we do to recall our customer, it's very simple. We send them a letter when they are due an appointment. And if for some reason they decide not to book an appointment, then we send them a letter every 3 months to remind them that they should book an appointment because they are due. So COVID-19 happened early 2020. And as a response, eye care services were restricted or withdrawn, and that led to millions of missed appointments, delays in treatments, and extended waiting times for patients. For Specsavers, this represented not only a huge loss in revenue, it also created an enormous backlog of overdue appointments. Bless you. So during the 3 months, our clinics were closed or running on restricted service. We registered an 80% drop in the number of sight test appointments. But most importantly, conditions such as glaucoma were not picked up, and they weren't dealt with in a timely fashion, leading to vision loss and, in some extreme cases, into blindness. Our data showed that during that period, we had a 66% drop in our referral for such conditions. So I started at Specsavers in this context. I started in July 2020. I was hired as the first data scientist there, and our data team was just at the beginning of their data transformation journey. So we were really eager to demonstrate to the business how data and data science could really help to support business function and decision making. So we decided to build a propensity model. We would build a model that would calculate how likely a customer is to book an appointment. And for that, we needed data, all sorts of data. We needed CRM data, so we use Adobe data, which is our CRM tool. And to know, for example, how many letters they received in the last 12 months. We used as well their past appointment time, appointment dates. We looked as well as their test results, their prescription. We also looked at past purchase behavior And finally, we looked at some demographic data. We pulled some of it from the Office for National Statistics, and we also used a model provided by Experian that groups together customers that share the same demographic, lifestyles, and behavior. So once we had the data, we looked at what we were expecting to see as an outcome. So really, it's a very simple classification problem. You can answer this question by yes or no. Are they going to book? Yes, no. So we had 4 scenarios possible. And while we want to optimize the true positive and the true negative, it's important to identify what the incorrectly classified customer mean for the business. And in this instance, the false positive represents a cost, because we would contact those customers despite them not booking, while the false negative represents a loss of revenue, since those customers would have booked if reminded. So now that we kind of knew what to expect with the model, we were ready to start building. And the first thing we did was to create a baseline model. So what I call a baseline model is a model that you create using minimum data manipulation, minimum feature engineering. You literally take your data, throw it to the wall, and look at what sticks. So this is what we've done. And this is the result of this baseline model. This has the advantage to give you an idea of what result to expect, and it gives you this baseline, this benchmark where you can start improving upon. And what we saw with these results, that they weren't great. I mean, they're not bad, but they're not great either. But at this stage, it doesn't really matter. What we see really that the model fails to accurately differentiate customers that are booking with customers that are not booking, can't differentiate these actions. So from there, we could have just started feature engineering, trying to improve our metrics and doing maybe some RFE. But because it's a model that was for commercial purposes, we decided to do a commercial analysis on it to really identify the metrics to improve and that make business sense. So we did just that. And what we found that was each false negative, which is an incorrectly classified customer that would have come if reminded, was a loss of revenue that was 200 times greater than the saving we made for a false positive. So from there, we knew that what we had to do and what made a business sense was to increase our proportion of positive customers, and that being true positive or false positive. And that translated into improving our recall metrics. And that would also come with sacrificing our precision. But we were fine with that, as long as we didn't lose the revenue. So focusing on the recall metric, we managed to deflate our number of false positive by 3 percentage points, and we were really happy with that. We have a few false positive customers, but again, we're fine with that because we can take the cost in as long as we don't have too many false negative. So from there, we decided to investigate the model, trying to understand what real feature impact the outcome of the model. And what we found was a bit alarming. We found that really there was one variable that really impacted the outcome of the model, and that was how many letters the customer received. So we decided to understand it a bit better and dug a bit deeper, and we realized really that there were 2 types of customers. We had the early responders that would book an appointment within the 6 months of being overdue, and then there was the delayers, those that are going just to wait a bit longer before booking their appointments. And because we have 2 very different behavior, then the problem needed to be addressed separately. So from there, it made sense to focus our attention on the delayers, we decided to send a letter to all the customers that are within that first 6 months period, and it was in line with our philosophy as a business and our duty of care. We'll make them aware that they are overdue an appointment and they need to book it, while for the customers that are 6 months or more overdue, we would use the model as a campaign selection tool to contact the right customers. So doing that, we built yet another model, and we got this result. And I'm sure what is striking in this result is the number of true negative. And this is because removing those early responders created a huge imbalance in our data set. And this is what is represented in here. But we were quite happy with that. We had a good number of positive customers. We still had a low false negative. So we were quite happy with that and decided to investigate the model. And what we found was a bit healthier than the last one. The model was really primarily related to seasonality, past appointments, age, and previous medical records. So using that and looking at explaining the model a bit deeper, we created some criteria for our customers that seem to be more likely to book an appointment. And those are customers, like we said, early in their recall journey. We have loyal customers, seem to be more likely to book an appointment. We have as well demographic data, such families and pensioners are more likely to book. We also have people that are happy to share their GP with us, so that might be because they have underlying conditions such as diabetes or hypertension that affect your sight. But it might also be just customers that value their eye health, understand that it's a medical provider and therefore share their GP with us. We also found that some age ranges are more likely to book an appointment, and those ranges are basically where your sight tend to change faster than when you're in your 20s or 30s. So it was in line with what we could see in our clinics. So once we had all of that, all these criteria, we had our data, we had our model, we understood our model, we were ready to build our pipeline. So to build our pipeline, we used the Azure suite. We're very much a Microsoft-led business. And at the top, you can see all the data sets that we used. They are stored in our lake, Azure storage, and they're picked up by a first script that basically just is a bunch of functions that are going to clean, do some feature engineering, merge the data together, and output a feature matrix. This feature matrix gets saved into the lake, Azure storage, and picked back up by the second script, which is our prediction script. And this one is just going to run some checks, making sure that the feature matrix looks like what it should, and that the data types are the correct one, and it passes it through the model and generates the output. From there, the data science job is kind of over, but there's some data engineering to do. And for that, we use Azure Data Factory. We pick up the prediction. We do some further manipulation to make it into a friendly format for Adobe to ingest, because this is our CRM tool. And just like that, it's available to our campaign manager and fully automated. So we were really pleased with that. We had everything we needed. Now it was time to implement and test our model. So the first thing you do when you give a model to your stakeholders or your clients is to make sure that they understand what the model can support and what it can't support. So in this instance, this model has been built to support the booking rate, to increase the booking number, and in turn, that can help increase the return on investment for the campaign. However, the model cannot give any indication on the attendance rate. It cannot flag the customers that are likely to miss their appointment. And similarly, it can't give any indication on how likely the customer is going to convert and buy a pair of spectacles after its site test. And these two really problems should be addressed separately, and we should build models for those. And finally, this model cannot provide any score for new customers. So once the campaign manager were aware of the limitation of the model, we were ready to give some recommendations. And we found that if we target our top 25% customers, we will still expect over 65% of our bookings. And this is just because the lower your booking rate gets, the slower your cumulative booking rate gets. In this analysis, we looked at the booked appointments using the model for campaign selection against the average booking rate. What we found was that at 50%, we get a 16 percentage points gain, while at the top 10%, we get a 60 percentage point improvement. So really exciting results. And what we decided to do was to target our customers for the campaign that scored between 60% and 90%, so the 10 to 40% top scorers. And with that, we were still expecting to get about 70% of our expected bookings. So give some customers to a data scientist, and it's just going to put it into buckets, and this is exactly what we've done there. We put our customers into buckets depending on their scores, and what you can see there is that the lower propensity customer, we expected about 2 out of 5 to book an appointment. In the medium one, we expected about over half to book an appointment. And finally, in the highest group, we expect 4 out of 5 to book an appointment. So now that we had all of that clear and we were ready to go, we launched the campaign. And the campaign was launched beginning of this year. And these are the results. So in terms of booking number, we got an uplift of 30%, which was really exciting, which meant that we had over 6,000 extra bookings that were made because of the use of the campaign selection. But most importantly, we looked at the revenue per communication, and we were really excited to see that the model was performing in line with our expectation, meaning that the greater the propensity to book, the greater the booking rate, and the greater the revenue per communication. So it was a successful campaign, and we were really excited to implement it in other areas. So what's next for the booking model? Well, like I said, we are going to use it to increase the traffic into our clinic during the off-peak periods. We also want to use it in our win-back campaign to target the customers that are the most likely to actually book an appointment. We also use it in retrospective analysis for CRM. And finally, and probably most excitingly, we are looking into replicating it into other regions and markets, particularly the Northern European market where we have clinics. And that is it about my presentation. Thank you very much for listening.